Okay. And this is our third gas law, Gay Lussac's law. This one is pressure and temperature very directly. So there's our equation. And it looks just like the last law we had, the one for volume and temperature, because a direct relationship is always the same. And since we have temperature, whenever we have temperature in a gas law, must be in Kelvin. So, same thing, we've got an equation to do. We've got a word problem. So, we have a pressure of 2.5 atmospheres. That's P1. And a temperature of 0 degrees Celsius. There's T1. So that's 273 Kelvin. To what temperature? So this time we've got T2 as our unknown, and our P2 is 4 atmospheres. So our prediction, pressure went down. No, pressure didn't go down. Pressure went up from 2.5 to 4, so temperature is also going to go up, so T2 is going to be greater than 273 Kelvin. So if it's not, we know to check our work. So our equation with no numbers in it. And that's what we're solving for, right there, T2. Hey, and think algebra. You can't solve for something while it is in the denominator. So you've got to do some algebra to get it out of the denominator. So there's more than one way to do some algebra on this. So you can flip it. Because the relationship's still the same. And there you go. You could also cross multiply. And you see either way, you get the same thing. So we have 4 atmospheres times 273 Kelvin divided by 2.5 atmospheres. Atmospheres cancel. So you have 4 times 273 divided by 2.5, and we get 436.8 Kelvin. only 2 sig figs are you allowed. It's 440 Kelvin. Okay, so pause and try your practice problem. Okay, pressure of 4 atmospheres. P1, 25 degrees Celsius. T1, add 273, and we get 298. Temperature inside the can is increased to 402 degrees Celsius. So there's T2. Add 273. We get 475. What will be the pressure? So P2 is our unknown. And then in this one we have an extra question. The container may explode if it exceeds 8 atmospheres. Would we expect it to explode? So our equation, P1 over T1 equals P2 over T2. Multiply both sides by T2 so that we get P2 alone. Plug our numbers in. Kelvin cancels. 475 times 4 divided by 298. And we get 6.3758 atmospheres. So 6.4 atmospheres when we round it to significant digits. So the answer to the question. We would not expect it to explode. It's less than 8 atmospheres.